This conference will now be recorded.
Good evening to everyone. In today's class, we are going to start the new chapter, matrices. What is a matrix? A matrix is an ordered rectangular array of numbers or functions. So we can order either numbers or functions in a rectangular form. That is called a matrix. The numbers or functions are called the elements or entries of the matrix. Okay. The numbers or functions are called the elements or the entries of the matrix. Usually we denote matrices by capital letters. Okay. These are the examples for matrices. Next, we see some basic definitions. Order of a matrix. How do you define order of a matrix? A matrix having m rows and n columns is called a matrix of order m cross n. If a matrix contains m rows and n columns, then we call it as a matrix of order m cross n, or simply m cross n matrix. It is read as m by n matrix. M by n matrix. M is number of rows and n denotes number of columns in a matrix. Okay. For example, here we can see examples for matrices. See the first matrix A. A is a matrix of order. What is the order? How many rows are in A? How many rows? There are 3 rows and 2 columns. There are 2 columns. So this is a 3 by 2 matrix. This is a 3 by 2 matrix. 3 cross 2 matrix. Okay. Next, come to the second matrix B. Here, how many rows you can see? There are 3 rows and 3 columns. There are 3 rows and 3 columns. So this is denoted by 3 cross 3. Okay. 3 cross 3 or 3 by 3. The next matrix is C. Here we can see 2 rows and 3 columns. 2 rows and 3 columns. So this is denoted as 2 cross 3. 2 cross 3. So this is what order of a matrix. Here. So in general, an M cross N matrix has the following rectangular array. This is the general form of a matrix, M cross N matrix. That means number of rows is M and number of columns is M. It has M rows and N columns. See the first row A11, A12, A13. It goes on. This is the jth column A1J, etc. A1. Okay. Then A21, A22, A23, etc. A21. The last row is mth row. This is the mth row. This is the first row, second row, third row. It goes on up to mth row. What is mth row? AM1, AM2, AM3, AMJ, AMN. This is the first column, second column, third column, and this is the jth column. This is nth column. Okay. This is mth row, nth column. So the corresponding entity or entry is AMN. These are all the elements of the matrix, say A. Okay, so it is usually denoted as matrix Aij. This is the matrix notation, matrix Aij. Aij are the elements of capital A. Small aijs are the elements of capital A. Elements are entries of capital A. This is M cross N. Order is M cross N or M by N matrix. Okay, I varies from 1 to M and J varies from 1 to N, where I comma J belongs to the set of all natural numbers. N means natural numbers. Okay, I and J takes values from natural numbers. So this is how we are denoting the given matrix. Let's see some examples. How to write the given information in terms of matrix. Okay. Consider the following information regarding the number of men and women workers in 3 factories. Factory 1, Factory 2 and Factory 3. Okay, we are going to represent this information in the form of a matrix. Okay, so any information can be represented in the form of a matrix. If you are able to represent the given data in the form of a matrix, then it is easy to solve the problem. Okay. So here some numbers are given: 30, 25, 27. These are all men workers. 30 men workers are working in factory 1 and 25 men workers are working in factory 2. 27 are working in factory 3. Similarly, 25 are working. 25 women are working in factory 1. 31 working in factory 2 and 26 are working in factory 3. So we are going to represent the above information in the form of a matrix. How many rows and how many columns? Okay, 30, 25, 27. What it is? It is men workers working in 3 different factories, and the second column represents women workers working in 3 different factories. Okay. So the above information now is represented in the form of a 3 by 2 matrix. There are 3 rows and 2 columns. So we have represented it in the form of a 3 by 2 matrix. So the entry in the third row and second column. Third row and second column. Third row is this. This is the second column. Okay. So it represents what? The number 26 represents what? The number of women workers working in factory 3. This is factory 1, factory 2 and factory 3. This is factory 3. So 26 represents the entry. 26 represents the number of women workers are working in factory 3. So any information can be represented in the form of a matrix. Right. Next, types of matrices. In this section, we are going to discuss different types of matrices. First, we have to learn the concept of matrices. Then only we will be able to solve problems. First one is column matrix. A matrix is said to be a column matrix. A column matrix is a matrix. First it is a matrix. Okay, so a matrix is a column matrix. Is said to be a column matrix if it has at least one column. If it has at least one column. For example, A equal to matrix 0, root 3, minus 1, 1 by 2 is a column matrix of order 4 cross 1. There are 4 rows and 1 column. So it is a column matrix of order 4 cross 1. In general, matrix A equal to matrix Aij over M cross 1. So number of rows is M and number of columns is 1. Number of column is 1. So this is a matrix of order m cross n. Next, row matrix. A row matrix is a matrix. If it contains at least one row, then we will say that it is a row matrix. For example, B is a row matrix of order 1 cross 4. There is only one row and 4 columns. So this is a row matrix. In general, B equal to matrix Bij over 1 cross n. This is a row matrix of order 1 cross n. Next, we are going to define square matrix. What is a square matrix? A matrix in which the number of rows are equal to the number of columns is said to be a square matrix. Okay, so in a square matrix, number of rows is equal to number of columns. So M cross N matrix is said to be a square matrix, means if M equal to N. What is M? M represents the number of rows and N represents the number of columns. So if M equals N means, then we say that the given matrix is a square matrix of order N. Okay, for example, A is a matrix. It is a 3 by 3 matrix. Here there are 3 rows and we can see 3 columns. Here the number of rows is 3 and number of columns is also 3. Since both are equal, we say that matrix A is a square matrix of order. So in general, A is matrix Aij over M cross M. See, M cross M. So what is your N? It is also M. So this is a square matrix of order M. Okay, it's like a square. Number of rows equal to number of columns. Next one is diagonal matrix. A square matrix, a diagonal matrix should be a square matrix. Okay, a square matrix B, matrix Bij over M cross M is said to be a diagonal matrix if all its non-diagonal elements are 0. All its non-diagonal elements can be 0. Okay. That is, the matrix B equal to matrix Bij over M cross M is said to be a diagonal matrix if Bij equal to 0 when I is not equal to J. That means all non-diagonal entries can be 0. For example, see matrix B equal to minus 1, 0, 0, 2. Here we can see 2 rows and 2 columns. As I said, a diagonal matrix should be a square matrix. Here B is a square matrix since number of rows equal to 2 and number of columns equal to 2. Both are equal. It is a 2 by 2 matrix. Okay, the order of matrix B is 2. See the non-diagonal elements. What are the non-diagonal elements? This is the first element, right? A11. What is A12? First row, second element. So it is denoted as A12. Then 0 is in the second row. So how will I denote? A21. Second row, first element. And 2 is A22. Second row, second element. So A11, A12, A21, A22. Right. Now see A11 and A22 are diagonal elements. What are the non-diagonal elements here? A12 and A21. These elements can be 0, but A11 and A22 cannot be 0. Okay, so can be 0. If it is 0, then we will call it as a 0 matrix. The entire matrix is 0 means it's a 0 matrix. All the entries, if all the entries in a given matrix is 0 means it's a 0 matrix. So here A12 and A21 are 0. These are the non-diagonal entries. And A11, A22 are diagonal elements. So here the next matrix, see the next one. What is minus 1.1? How will you denote it as A1V? It's a 3 by 3 matrix. Number of rows is 3 and number of columns is 3. So it is a matrix of order 3. C is a matrix of order 3. It's a square matrix, right? So minus 1.1 is first row. Sorry, this is A11. This is A11, first row, first element. Then A12, first row, second element. This is first row, third element, A13. Then in second row, the first element is 0. This is A21. This is A22. And this is A23. Okay. And this is the last row. That means third row. So this is A31, third row, first element, third row, second element, then third row, third element, A3. Right. So here A11, A12, sorry, A22, A33. A11, A22, A33. These are all diagonal elements. Right. Next, scalar matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. All its diagonal elements are equal. Say for example, matrix B equal to minus 1, 0, 0, minus 1. Here the diagonal elements are minus 1 and minus 1. Since all the diagonal elements in B are equal, it is a scalar matrix. Okay, what is the scalar here? Minus 1. This is also a matrix of order 1. Here we have only one element, so it is a matrix of order 1. And if you see the next matrix C, here the diagonal elements are root 3, root 3, root 3. Here all the diagonal elements are equal, so it's a scalar matrix of order 3. This is a scalar matrix of order 2, and A is a scalar matrix of order. Next one is identity matrix. What is meant by an identity matrix? In a square matrix, if all the diagonal elements are equal to 1 and rest are all 0, and the rest of the elements are 0, then we call it as an identity matrix. In a square matrix, if all the diagonal entries are 1 and if the rest of the entries are 0, then we say that it is an identity matrix. This is the definition. Aij equals 1 if I equal to j. Okay, if I equal to j, and 0 if I is not equal to. See here, the diagonal entries are 1, 1, 1. All the diagonal elements are 1 and rest of the elements are 0. So it is an identity matrix of order 3. 3 by 3 matrix, so order 3. See the next matrix 1, 0, 0, 1. It is a 2 by 2 matrix. The number of rows and number of columns both are 2. Okay, the diagonal entries are 1, 1, equal entries, and other elements are 0. Okay, so it is an identity matrix of order 2. One is the matrix 1 is, yeah, 1 is an identity matrix of order. Next one is 0 matrix. A matrix is said to be 0 matrix or null matrix if all the elements in a matrix are 0. Okay, we denote it by O. Next, equality of matrices. When will you say that two matrices are said to be equal? Two matrices are said to be equal. Let A and B be any two matrices. A is matrix Aij and B is matrix Bij. I am going to say that matrix A and matrix B are equal. Matrix A and matrix B are equal. When it is equal, they are of the same order. What is the first condition? They are of the same order. A and B, they have the same order. The second condition is each element of A is equal to the corresponding element of B. Each element of A is equal to the corresponding element of B. What does it mean? Aij is equal to Bij for all Ij, for all Ij. See, for example, there are two matrices given here. The first matrix is 2, 3, 0, 1, and the second matrix is also 2, 3, 0, 1. Okay, both are maintaining the same order. It is the first matrix is of order 2 and the second matrix is also of order 2. Both are square matrices. Okay. Each element of A is equal to the corresponding element of B. What is the first element of A? What is the first element in B? It is also 2. So 2 is equal to. What is the second element in A? It is 3. A12 is 3. Similarly, in B also, A12 is 3. Like that, A21 equal to 0 and A22 equal to 1. So, in these two matrices, we see that each element of A is equal to the corresponding element of B. And they are of the same order. So, A and B are equal. Okay. But these two matrices are not equal because here A11 is not equal to B11 and A12 is not equal to B12. So symbolically, if two matrices A and B are equal, then we write A equals B. See this example, if the matrix X, Y, Z, A, B, C is equal to some matrix is given in the right hand side. So from this, what we can say? If these two matrices are equal means then X is equal to minus 1.5, Y equal to 0, Z equal to 2, A equal to root 6, B equal to 3 and C equal to 2. Provided if these two matrices are equal only. Okay. Next, see this example. Some matrix is given in the left hand side which is equal to some matrix. There's 0, 6, 3y minus 2, minus 6, minus 3, 2c plus 2, 2b plus 4, minus 21, 0. Both are 3 by 3 matrix. Order is 3. We are asked to find the values of A, B, C, X, Y, and Z, unknown values. We are going to find the unknown values. These two matrices are equal matrices. So I will write x plus 3 equal to 0. Since these two matrices are equal, A11 equal to B11, A12 is equal to B12, A13 equal to B13, A21 equal to B21, A22 is equal to B22, A23 is equal to B23. Similarly, A31 equal to B31, A32 is equal to B32, A33 is equal to B33. How do you know that these two matrices are equal matrices? Since B32 is equal to A32, both are minus 21. Similarly, A33 is equal to B33, both are 0. Right? So, similarly, A21 is equal to B21. This is minus 6. So these two matrices are equal matrices. Using this concept, we can get the values of unknowns. So if you equate, then you are getting 6 equations, right? 6 equations. 6 equations and it involves 6 unknowns. Okay, so 6 equations in 6 unknowns. If you simplify, then you will get the values of x, y, z, a, b, c. That you can easily find. Similarly, find the values of A, B, C, and D from the following equation. Another example is given like this. So, how will you do this? 2a plus b is equal to 4, a minus 2b is equal to minus 3, and 5c minus d equal to 11, and 4c plus 3d is equal to 24. Okay. Using the concept of equality of two matrices, you are getting 4 equations in 4 unknowns. Solve these 4 equations, get the values of a, b, c, and d. Some examples and exercises are given, and go through that. Next, operations on matrices. In this section, we are going to discuss certain operations on matrices, namely addition of matrices, subtraction of matrices. That's what difference, and the multiplication of a matrix. Sorry, multiplication of a matrix by a scalar, and multiplication of matrices. Addition of matrices. How we can add two matrices? Is there any condition imposed on addition of matrices? Here the matrix A, that is factory at A, this is of order 3 rows and 2 columns. So it is 3 by 2 matrix, and this is also 3 by 2 matrix. So we can add easily. How will you add? A11 plus B11, A12 plus B12, A21 plus B21, A22 plus B22, A31 plus B31, A32 plus B. So 80 plus 90, 60 plus 50, 75 plus 70, 65 plus 55, 90 plus 75, and 85 plus. Okay, you can add directly. So this is a formal definition. If matrix A is A11, A12, A13, A21, A22, A23, this is for example. It's a 2 by 3 matrix, 2 rows and 3 columns, and matrix B is another 2 by 3 matrix. Then we define A plus B. Then we define addition of A and B. Addition of two matrices A and B as A11, B11. So A11 plus B11, A12 plus B12, A13 plus B13. In general, if it is a M cross N matrix, M by N matrix, then you will have A11 plus B11, A12 plus B12, etc. A1 N plus B1N. Okay. Here it's a 2 by 3 matrix. So in the second row, you will have A21 plus B21, A22 plus B22, A23 plus B23. So in general, if A and B are two matrices of the same order, then the sum of the two matrices is defined as a matrix. Sum of two matrices A and B is also a matrix C. It is denoted by It is denoted by the letter C. It's a matrix Cij over M cross N. Where Cij is Aij plus Bij. That is A11 plus B11 will give you C11. Okay. An example is given here. A is a matrix of 2 by 3, 2 rows and 3 columns. 2 rows and 3 columns. Okay. And B is also a matrix of order 2 by 3. We have to find A plus B. So what is A plus B? Here A and B are of the same order 2 by 3. So A plus B will give you a new matrix, namely C. What is C? A11 plus B11. That is C11. Okay, what is C11? C11 is an element of C. So what is C11? How you are defining? The addition is A11 plus B11. A11 plus B11. So it gives root 3 plus 2. And what is C12? C12 is A12 plus B12, right? A12 plus B12. So it gives 1 plus root 5. And C13 is minus 1 plus 1. It becomes 0. Next, C21, second row, first element. It is A21 plus B21. A21 plus B21. So 2 minus 2 will give you C21. That's 0. 2 minus 2 is 0. Then 3 plus 3 is C23. It is 6. Then 0 plus half. It is half, which is C33. C33 is A33 plus B. Yeah. Okay. If A and B are not of the same order, if A and B are of the same order, then addition is, we can define addition, right? A and B are of the same order means then we can define addition. Suppose A and B are not of the same order, then can we define addition? No, we cannot define addition. A plus B is not defined. Okay. For example, if A is 2 by 2 matrix, here 2, 3, 1, 0, the elements of A are, and B is another matrix. It is, yeah, 2 by 3 matrix, 2 rows and 3 columns. But A is a 2 by 2 matrix, whereas B is a 2 by 3 matrix. Here the order is not same. So I cannot add A and B. I cannot add A and B, right? Next, multiplication of a matrix by a scalar. See this example. Quantities produced by factory A are here, quantities produced by factory A is represented in the form of a matrix, boys and girls. Okay. Revised quantities produced by factory A are as given are as given below. So here they have multiplied each entry by some scalar. What is a scalar here? 2. Okay, they are multiplying each element of the above matrix by 2. So it gives 2 into 80, 2 into 75, 2 into 90. So this is what scalar multiplication. So in general, K into A. K is any scalar. Okay. K into A is K into what is A? A is a matrix Aij over M cross N. It gives K into Aij. So each element, we can multiply each element of A by K. We can multiply each element of A by K, where K is a scalar. For example, if matrix A is a 3 by 3 matrix, then what is 3A? How will you find 3 times A? I want 3 times A. A is given to you. I want find 3A. Okay. So what is 3A? 3 into, this is your matrix A. Which means I have to multiply each element of A by 3. I have to multiply each entry of A by 3. So it gives 3 into 3, 3 into 1, 3 into 1.5, 3 into root 5, 3 into 7, 3 into minus 3, 3 into 2, 3 into 0, 3 into 5. That is your resulting matrix. Next, negative of a matrix. What do you mean by negative of a matrix? Negative of a matrix is denoted by minus A. Okay, negative of a matrix is denoted by minus A. It is defined as minus A as minus 1 into A. Minus A is defined as minus 1 into A. So what is this minus 1? This minus 1 is nothing but a scalar. Here the scalar is minus 1. So What you're doing is you are multiplying each element of A by -1. So if you multiply each entry of A by -1, then it gives minus A. So your scalar is here -1. Okay. So see for the see this example. A is 3, 1 minus 5x. Then what is minus A? Minus A is, by definition, it is -1 into A. So -1 into what is your matrix A? 3, 1 minus 5 into x. So I have to multiply each element of A by -1. Gives -3 -1, 5 -6. Next, I am going to define difference of matrices. Difference of two matrices. How will you define difference of two matrices? A and B be any two matrices in the same order. Same. Say A is a matrix Aij of M cross N and B is a matrix Bij of M cross N. Then what is the difference of A and B? It is denoted by the symbol A difference B. A difference B. A difference will give you a new matrix, namely D. Okay, A difference B gives a new matrix, say D. What is D? D is a matrix Dij. The elements of D are Dij. D is also a matrix of order M cross N. E is of order M by N. How I am defining the elements of D? Dij is equal to Aij minus Bij for all values of Ij. This is nothing but subtraction of two matrices. Difference is nothing but subtraction of two matrices. This is like how we have defined the addition of two matrices earlier, right? So this is subtraction of two matrices. So in other words, D is A minus B. A minus B can be written as A plus -1 into B. So what is this -1? -1 is a scalar, or -1 into B is nothing but a negative of a matrix B. So I have defined difference of two matrices in terms of sum of two matrices, in terms of addition of two matrices. Actually, D is A minus B. How I have defined here? A plus -1 into B. So this is written in the form of sum of two matrices, namely A and the matrix minus B. A and matrix minus B. See this example. If A is a 2 by 3 matrix, 2 rows and 3 columns, and B is also a 2 by 3 matrix, then only we can define subtraction. Otherwise, we cannot define subtraction. The order is not same, then we cannot define difference of matrices. Okay. We have to find 2A minus B. A minus B. So how will you find 2A minus B? 2 into A. This is A minus B. So what is the scalar here? 2. So I need to multiply each entry of A by 2. It gives 2 into 1. 2 into 2 is 4. 2 into 3 is 6. 2 into 2, 4. 2 into 3, 6. And 2 into 1 is 2. So this is your 2A. Okay. Plus, minus B. What is B? B is this. Now I'm going to bring this minus inside the bracket. Okay. So here I will put plus. So now I have to multiply each element of B by -1. So if you multiply, then you will get -3 plus 1 minus 3 plus 1 0. So now I'm going to add these two matrices. 2 minus 3, 4 plus 1, 6 minus 3. That is the first row. And the second row is 4 plus 1, 6 plus 0, 2 minus 2. So it gives -1, 5, 3, 5, 6, 0. Okay, so this is 2A minus here. So far we have learned what is a matrix, okay, how we can represent a matrix, then what are the different types of matrices. Then we have defined Operations on matrices. We have learned four operations. One is addition of two matrices, difference of two matrices, then scalar multiplication. The fourth one is multiplication of matrices that we will discuss it later. Before that, we should know what are the properties of matrix addition. Properties of matrix addition. There are two properties. One is commutative law and four properties. Commutative law, associative law, and additive identity, existence of additive identity, then existence of additive inverse. So these are the four properties of addition of matrices. Addition of matrices. What do you mean by commutative law? If A and B are any two matrices of the same order, if A and B are any two matrices of the same order, say M by N, then A plus B equal to B plus C. This is what commutative law. A plus B is equal to B plus C. Both are equal. Like numbers, no? 5 plus 3 gives 3 plus 5. Like that, in matrices, we have commutative law. Matrices will satisfy the commutative law and associative law. For any three matrices, say matrix A, B, C, are of the same order, say M by N matrix, then A plus B plus C is equal to A plus B plus C. Both are equal. Okay. We add A and B, then A plus B plus C gives A plus B plus C. Both sides are equal, associative. Then existence of additive identity. Like A equal to matrix Aij be an n cross n matrix, and O is zero matrix of order m cross n. Then A plus O is O plus A is equal to A. In other words, O is the additive identity of matrix, additive identity for matrix addition. Okay. This is for example. In real numbers, if you add any number with 0, then you will get the same number, right? 2 plus 0 is equal to 2. This is also 0 plus 2. That in matrices we have A plus 0 matrix is equal to 0 matrix plus A equal to the same matrix. Then existence of additive inverse. What is the additive inverse? In real numbers, we have minus 2 plus 2 gives 0, right? So like that in matrices A plus minus A. A is a matrix of order m cross n, and minus A is also a matrix of m cross n. So A minus A is minus A plus A is equal to 0 matrix. Okay. If you get additive identity, then minus A is called the additive inverse of A. If you get additive identity here, then minus A is called the additive inverse of A. Minus A is called the additive inverse of A. So in natural numbers, the additive inverse is minus A in general. Natural numbers, minus A is the additive inverse and 0 is the additive identity element. Additive identity element. Okay. Next, properties of scalar multiplication of a matrix. Let A and B be any two matrices of the same order, say M by N matrix, and K and L are scalars. K and L are scalars. What is the first property? K times A plus B gives K into A plus K into B. We can bring this K inside the bracket. It will give you K into A plus K times B. Similarly, K plus L. If I add this, if I add the two scalars, K plus L into A. Okay. A plus L is multiplied by A is K into A plus L into K. These are the two properties of scalar multiplication of a matrix. See this example. If A is a matrix of 3 by 2 matrix and B is a matrix of order 3 by 2, then find the matrix X such that 2A plus 3X equal to 5B. 2A plus 3X equal to 5B. A is given to you and B is given to you. What you have to find is X. You have to find the matrix X such that what is the condition given? 2A plus 3X equal to 5B. Okay, we have to find a matrix A in such a way that 2A plus 3X equal to 5B. We have 2A plus 3X equal to 5B. So this is 2A plus 3X minus 2A is equal to 5B minus 2A. So what I am doing here is I am subtracting 2A on both sides. Subtracting 2A on both sides. Okay. Then we have studied that matrix addition is commutative. Matrix addition is commutative. What does it mean? A plus B. If I add A with B, then it is same as B plus C. The same as B plus C. This is what? Commutative law. So here I am going to use this law, commutative law. By this law, this is your capital A. This is your B, right? So what is commutative law? A plus B is same as B plus A. Both are equal. Okay. So this is your A and this is your B. Okay. Sorry. This is A and this is B. You don't touch this. 3x minus 2a. Here I have 3x minus 2a. So by commutative law, this is minus 2a plus 3x. Both are equal. A plus b is equal to b plus a, right? A plus b equal to b plus a. So 3x minus 2a equals minus 2a plus 3x. 3x minus 2a equals minus 2a plus 3x by commutative law equals 5b minus 2a. What is 2a minus 2a? 2a minus 2a gives 0 matrix because minus 2a is the additive inverse of 2a. Minus 2a is the additive inverse of 2a. Yes. Minus a is the additive inverse of a, right? Minus a is the additive inverse of a. If you add a with minus a, then it will give you a 0 matrix. If you add a with minus a, what is a plus minus a? It is 0. A plus minus a is 0. What is 0? 0 is an additive identity element. Okay, 0 matrix. Here 0 matrix, that is matrix O. Matrix O is an additive inverse of matrix O is an additive identity. Okay, additive identity matrix. So this is O plus 3x equal to 5b minus 2a. If you add 3x with 0 matrix, then it will give 3x only. If you add any matrix with 0 matrix, then you will get the same matrix, right? So it gives 3x is equal to 5b minus 2a, 5b minus 2a. From this I can find x. What is x? My x is 1 by 3 times 5b minus 2a. 1 by 3 times 5b minus. So 1 by 3 times 5b means, what is 5b? B is given. So I have to find 5b. What is 5b? 5 into b minus 2 into a. Here 5 is a scalar and b is a matrix. So here I have to apply scalar multiplication of a matrix. Scalar multiplication of that. So I have to multiply each element of b by 5. Each element of b by 5 gives 5 into 2 is 10. 5 into minus 2 minus 10. 5 into 4 20. 5 into 2 10. 5 into minus 5 25. 5 into 1. This is your 5b. Minus 2a. Again scalar multiplication of a matrix. I'm going to bring this minus 2 inside the matrix. Okay. So now we are going to multiply each element of a by minus 2 gives minus 2 into 8 minus 16, minus 2 into 0 0, minus 2 into 4 minus 8, minus 2 into minus 2 4, minus 2 into 3 minus 6, minus 2 into 6 minus 2. Correct. If you simplify, then you will get this matrix. Okay. Outside we have 1 by 3. So again 1 by 3 is a scalar, right? So we have to bring this 1 by 3 inside the bracket, inside the matrix bracket. So minus 6 by 3, minus 6 into 1 by 3. Then minus 10 into 1 by 3, which is minus 10 by 3, 12 by 3, 14 by 3, minus 31 by 3, minus 7 by 3. So that is the final answer. Here. And next problem is find x and y. We have to find x and y. If x plus y is a matrix, 2 by 2 matrix, and x minus y is also a 2 by 2 matrix. What we have to find? We have to find what is x and what is y. Sum of two matrices is 5 by, it is 5209, and difference of two matrices is 3, 6 and 0 minus 1. We are asked to find x and y. Okay, I am going to add these two matrices, x plus y and x minus y. So x plus y and x minus y. These two matrices are given to you. We have to find x and y. I am going to add these two matrices. X plus y plus x minus y in the left hand side. So in the right hand side, what will you get? 5 plus 3, 2 plus 6, 0 plus 0, 9 minus 1. It gives 8, 8, 0, 8. Here the diagonals are 8 and 8. So in the left hand side, what are you getting? Y minus y will give you 0 matrix. X plus x is 2x. So 2x equal to 8, 8, 0, 8. So from this, what is x? X is 1 by 2 times 8, 8, 0, 8. Okay, so we need to bring this 1 by 2 inside the matrix. What will you get? 8 by 2, 8 by 2, 0 by 2, 8 by 2. It is 4, 4, 0. Okay. Next, I am going to subtract these two matrices. If we add these two matrices, then you will get x. If you add, then y and y will get cancelled. I can find x. If you subtract these two, then y, x will be eliminated. In that case, you can find the value of y. So I'm going to subtract these two matrices, x plus y minus of x minus y. So 5209 minus the next matrix is 360 minus 1. If you add in the left hand side, then you will get x minus x plus y plus y commutative law. This is a zero matrix. Y plus y is 2y. Here I have to find the difference. So 5 minus 3, 2 minus 6, 0 minus 0, 9 plus 1. First you bring this minus inside. So it gives 9 plus 1. Simplify, you are getting 2. Here minus 4 is 0. This is actually 2y. I need y. So y is 1 by 2 times 2 minus 4, 0. Bring this 1 by 2 inside the matrix. You will get 2 by 2 minus 4 by 2, 0 by 2, 10 by 2. That's 1 minus 2, 0. So if you add these two matrices, then you will be able to find the value of x. If you find the difference between these two, then you can find y. The next problem is find the values of x and y from the following equation. Some matrix equation is given here, not the ordinary equation. It's a matrix equation. 2 times matrix x 5 7 y minus 3 plus 3 minus 4 1 2 is equal to this. So how will you do this? Here I have to multiply the first matrix by the scalar 2. So each entry of this matrix is to be multiplied by 2. Okay. So you'll get 2x, 2 into 5 10, 2 into 7 14, 2 into y minus 3 is 2y minus 6. Plus the second matrix is 3 minus 4 1 2 equals this. So I have to add these two matrices now. If you add, what will you get? 2x plus 3, 10 minus 4, 14 plus 1, 2y minus 6 plus. Okay. So if you simplify, then 2x plus 3, 6, 15, 2y minus 4 equal to this. These two matrices are equal matrices. So because here we have 15 and here also we have 15, and A21 is 6, B21 is 6. So these two matrices are equal matrices. Equal matrices means what you will do? You can equate the corresponding entries also, right? So you will get 2x plus 3 equal to 7 and 2y minus 4 equal to 3. Other two entries are equal. So equate these two, you will get two equations and two unknowns. If you solve these two equations, then you will get the values of x and y. X values 2 and y values. So with this we come to the end of this class. Have any doubts? If you have any doubts up to this, you can ask me. I'll wind up this session then. Thank you.